Assalamu alaikum students. Today we start next topic, elementary row and column operation on matrix. Usually a given system of linear equation is reduced to simple equivalent system by applying in turn a finite number of elementary operation which are stated as below. We interchange two equations, multiply an equation by a non-zero number, adding a multiple of one equation to another equation when we solve system of linear equations. Now we change in matrix form, and then three elementary operations. The following elementary operations are applied to matrix to obtain equivalent matrices. Same like equations, interchange two rows, multiply a row by a non-zero number, adding a multiple of one row to another row. Same process as we do in equation and in matrix, because we write matrix from equations. Notation we use when we interchange rows expressed as Ri interchanged by Rj. When we multiply any number like k times r is denoted by kr, and the new is r dash. Adding k times r to r is expressed as when we add a row in another row by multiplying it by any number, we write it like that. And same process in columns. Now we have a system of linear equation, we convert it in a matrix form, and we name them A, X and B. Also we can write like that. A is called the matrix of coefficient. Appending a column of constant on the left A, we get the augmented matrix. When we write column inside a matrix A, this matrix is called augmented matrix. Like that, here is A and we write a column inside A, and this matrix is called augmented matrix. Now another definition of upper triangle matrix. Here Aij is equal to 0 for all Ai greater than j, and lower triangle matrix when I less than equal to j, and both are called triangle matrix, either it is upper or lower triangle. These are their examples. First is upper triangle and second is lower triangle. Both are called triangle matrices. Now here example of symmetric matrix. when we transpose a matrix and it is equivalent to the original one, this is called symmetric matrix. Here are some examples. If we transpose these matrices, no change in them, and these are called symmetrics. And there is skew symmetric. If we transpose a matrix and it is equal to the negative of the original matrix, and this is called skew matrix. We have a matrix B, and then we transpose this matrix, and then we take -1 common from it, and B transpose equal to -B. Therefore B is skew symmetric matrix. Next is Hermitian matrix. Hermitian matrix, a matrix in which complex number also involved, and we take its bar and then transpose. Bar means conjugate. When we take bar, we change the sign of imaginary numbers, only imaginary numbers like iota. Here an example: A, when we take bar, minus iota become plus iota, and plus iota become minus, and then it's transpose and it is equal to A. Therefore A is Hermitian. Skew Hermitian, in which we take bar and then transpose and it is equal to -A. Therefore it is called like skew symmetric and skew Hermitian. At the end we take minus common. Here example, we first take bar, then it's transpose, and then we take -1 common, and this is equal to the original one. Therefore A is skew Hermitian. And this is process echelon and reduce echelon form of matrices. Echelon form of a matrix. Here some example, easy to understand. If all the entries below diagonal are equal to 0, this is called echelon matrix. And in reduced echelon form, the values below and above of a diagonal are all 0, and this is called reduced echelon form. Reduce the following matrix to row echelon and reduce echelon form. Here we have augmented matrix, and the process to make it reduce echelon and echelon form. First of all, at the first number we make a number 1. Either we divide it or replace by any other number in interchanging two rows. Here we interchange R1 m by R2 we change R1 by R2 here, and then we make 2 and 3, the below two numbers, equal to 0. Here we apply a rule of row method. We multiply first row by -2 and then add in R2 and multiply R1 by -3 and add in R3. By this process we get 0 0 in place of 2 and 3. The new values of R2 are 0, 5, -5 and 15, and new values of R3 are 0, 4 and -3, 11. How we get these values? We multiply R1 by -2 and add in R2, and then we multiply R1 by -3 and add in R3, and we prepare our first column 1 0 0 and to form a second column. First of all we make here 1 and in place of 5 we make 1. How we divide R2 by 5? We divide R2 by 5 and this leads R2 to 1, -1 and 3. And below this one there is a 4. We make 4 equal to 0. How it is possible? We multiply 4 by -4 by R2 and add in the third row. We multiply by the same number, which number we want to make it 0. And then we make -1 above 1 equal to 0. We simply add R2 in R1. Now we complete our second column. Now we move toward third column. Here we have at the bottom 1 and above -1 and 1. Now we add R3 in R2 to make -1 0 and R3 minus R1 to make above 1 is equal to 0. Now by this process we get identity. So this is the reduced echelon form. And the second last matrix is echelon form. Here we have zeros below diagonal. This is called echelon form. And if we make identity, this is called reduced echelon form. Here we find inverse of matrix A. In last exercise we find inverse by adjoint and divided by its determinant. Now here we find inverse by row method. First of all we find A determinant to make sure it is singular or non-singular. If it is singular, then we don't find its inverse. Now we find its inverse because it is non-singular. We write identity in the same matrix on its right side, and by row method we apply in the last example to make the first values, original values, equal to identity. By the same process, by same steps, we make first column, then second column, and then third column. And in first column we have 2, 3 and 1, and we want to make 2 is equal to 1. Here we interchange R1 by R3. This apply on the all 6 values of R1 and all 6 values of R3. We interchange these values, and then we make the below values 3 and 2 equal to 0. By the row method we multiply first row by -3 and -2 and add in the corresponding rows to make them 0. Now first column is prepared, and in the second column we have -2 in diagonal values. We make it 1 by divided by -2, and we divide all 6 values by -2. Now we make 1 and my 2 equal to 0. We subtract R2 and R3, which makes below 1 equal to 0, and then we multiply -2 by R2 and add in R1 to make the above 2 is equal to 0. By this process we complete our second column and we move toward the third column. Always try to do in the same method. Here we have 7, and then we first divide it by 7. Now we divide R3 by 7. Now we get it there 1, and we make above values 6 and -4 equal to 0. We multiply R3 by -6 and add in R1 and multiply by R3 by 4 and add in R2 to make it 0. Here we can see the first 9 values are equal to identities, and the next 9 values are called inverse of A. This is called row method. Now to find the inverse by column method, we write identity below A, now we prepare rows. First of all, in first point we want make it 1. We interchange our C1 by C3, 2 replaced by -1. To make it positive 1, we multiply it by minus 1, and then we want to make my 3 these two values equal to 0. Here we have 5, we multiply by minus 5 or C1 and add in C2, and minus 2 C1 and add in C3. Now in second row we have 14, we divide it by 14, we divide C2 by 14, and we get these values. And next we want to make minus 2 and 7 0. We multiply C2 by 2 and add in C1 and multiply by C2 by 7 minus 7 and add in C3. Next we want to make in R3 6 over 7 and more minus 4 over 7 equal to 0. We multiply by the same number C3 with negative sign and add in the C1, and we multiply 4 over 7 C3 and add in C2, and this leads to the inverse. Above 9 values equal to identity and below 9 values are inverse, and here we find inverse by column method. Next is rank of matrix. Let A be a non-zero matrix if R is the number of non-zero rows. When it is reduced to the echelon form, then R is called rank of the matrix. Here we augmented matrix, and in the same way we make it echelon form. First we prepare the first column, the same style. We have 1, 2 and 3. With the help of 1 we make 2 and 3 is equal to 0. We multiply R1 by minus 2 and minus 3, add in the corresponding values, and then in second column we have 2 in diagonal element, and we make it 1 by dividing by 2. Now here we get all values in R3 are 0. Therefore this matrix have rank is equal to 2, because in third row all the values are 0, and row and rank is equal to the number of non-zero rows, and non-zero rows are 2. System of linear equations. An equation of the form ax plus by is equal to k is called non-homogeneous linear equation in two variable x and y. Two linear equations in the same two variables are as is a system of non-homogeneous linear equation in the two variables x and y are constant and k1 and k2 are not both 0. If both are 0, then this is homogeneous, and if these are k1 and k2 not, 0, then this is called non-homogeneous equation. Same from 3 elements. If k1, k2 and k3 are 0, and this is called homogeneous, and if these values are not equal to 0, then it is called non-homogeneous equation. Same definition is there. Now here we have homogeneous equation, and x1 is equal to 0, x2 is equal to 0, and x3 is equal to 0 is its solution, and this solution is called trivial solution. And other than trivial solution is called non-trivial solution. For homogeneous equation, fixed solution is 0, 0 and 0, and other than this solution is called non-trivial solution. 0, 0, 0 is called trivial solution for homogeneous linear equation. Here we have system of linear homogeneous equation, and we find its determinant. Determinant is also equal to 0. We solve these equation to find its non-trivial solution. Because it is not possible, at the end we make the lost variable equal to another variable like t, because when we solve equation 1 and 2 and equation 2 and 3, we get the same answer, so its solution is not possible. We make the third variable equal to another variable called t and put these values in the above equation to make their answer in the form of t, and this is called non-trivial solution. Here we have the same example. Non-homogeneous linear equation, we have three methods. Matrix method we use in 3.3 to find A inverse, and in 3.2 by 2 cross 2 matrix, and second one is echelon and reduced echelon form, and third is Cramer rule. Here we have example. We write in matrix form, then we find its determinant. We solve it by matrix form method. Now we find its cofactor, then we find its adjoint and divide it by its determinant and multiply it by b, and we get the answer. Now to solve it by echelon method, we first write it in augmented matrix. We write values inside the matrix and this is called augmented matrix, and we make it echelon form by row method. And we have first column 1 4 3. We make 4 and 3 equal to 0. Here we multiply r1 by 4 minus 4 and add in second column, and multiply by minus 3 and add in third row to make it 0 0, and then we complete first column. And in second column we have in mid value minus 7. Now we divide it by minus 7. But here we interchange r2 by r3 and divide it by minus 11. And next we multiply. Why we interchange these rows? Because we divide by 11 to avoid fraction values. If we divide by 7, we have some fraction values and difficult in calculation. Now we make minus 7 equal to 0. We multiply r2 by 7 and add in r3. Next, in third column we have 18. We divide it by 18 to make it 1. Now we have, this is echelon form because we have 0 0 below diagonal. This is called echelon form. From last matrix we make these quotients, and here we get x3 is equal to 2. We put in the above quotient to get the value of x2, and x2 and x3 we put in the first quotient to get the value of x1. Next, the loss matrix, we make it reduce echelon form to make the above values equal to 0. We first make this 3 equal to 0. We multiply it by minus 3 and add in r1. And then we multiply by minus 5 and 1 to make the above values equal to 0. And by this process we directly find the values, as x1 is equal to 2, x2 is equal to minus 1, and x3 is equal to 2. Now the third method is Cramer rule. We write it in matrix form and find the determinant, and we have three variables x1, x2, x3. To find x1, we replace column 1 by the value of b. These are the values of b. And we divide it by the determinant. Now we find the determinant of above determinant and divide it by the original determinant to find the value of x1. and in x2 we replace b in place of second column. And then we find its determinant, and in x3 we replace b in third column and divided by the determinant 9. 9 is the determinant of A matrix, original matrix, and here we get the values of x1, x2 and x3 directly. Okay students, this is the last method to find the values. Hope you understand, and if you have any problem, don't hesitate to contact with me. Underline in the notes and question me any problem. Thank you and Jazakallah.